Welcome back to Spoonful of AI, where each week we talk to someone who's using AI to innovate or help them change or evolve their business. This week, Mike sits down and talks to a data scientist working for the past 9 years on computational gastronomy. He's been working to basically codify food, recipes, flavors, nutrition, and use that data in meaningful ways. AI and LLMs are part of this, and it's a fascinating conversation, so please enjoy. And then I'll be back next week talking to Ross Finman, and we talk about smart badges and the positive take on why you should support your local indie AI company. That's next week. This week, let's talk to Ganesh. Mike, take it away.
All right. Tell us who you are and what you do.
I'm Ganesh Bagler. I'm a scientist and a professor at IIIT Delhi. I'm affiliated to the Department of Computational Biology and Infosys Center for Artificial Intelligence. And for the last 9 years, I have been working to create foundations of a new discipline called computational gastronomy, about which we'll be talking.
That's great. And I ran across you in an article, I think it was on the BBC, talking about just this computational gastronomy. This is an area that fascinates me. I'd love to hear you describe and define what is exactly computational gastronomy.
When we look at food, we see it as a personal phenomena, something subjective. And we can't imagine food and the experiences that come with food to be quantified. Oftentimes, people hate that something as subjective and as personal can be quantified. But at the same time, I believe that food, which is a multi-sensorial experience, we experience it via taste, odor, vision, texture, and even sometimes audio, this experience can be codified, can be quantified. Computational gastronomy is a step towards that direction where every aspect of food is seen through the lens of data. I'm a computer scientist and a data scientist, so I love seeing things through the lens of data, and that's what we have been doing. So, computational gastronomy codifies every aspect of food, such as recipes, flavors,
Mhm.
nutrition, health associations, and carbon footprints by using data as the baseline.
So, why can we do this today versus maybe 10 years ago, 20 years ago? I mean, the broader world, I think as computers advance and sensors advance, we can seem to quantify it and understand it better? Is it just because of this large megatrend of compute getting better, AI getting better, and the sensors that we can use to quantify and understand the physical world are better?
Well, I think there are a couple of things that have happened here. One is, of course, in terms of compute becoming better. Second, access to data, access to
Mm.
digitized recipes data, for example, has increased. But every aspect of data that we have been gathering for the last 9 years has been around in one form or the other, mostly in the hard copies and published research articles for a long, long period of time, a few decades maybe. But I guess for some reasons, until to around a decade back or so, nobody thought that something as disparate and personal as food and cooking can be merged, blended with computing and data science. Even today, there are naysayers who don't believe that this can ever be possible. But for the last 9 years, our efforts have shown that interesting things can happen. And today, with the emergence of artificial intelligence, we can possibly come up with new recipes which cultures have never encountered, and maybe try making these recipes personalized, something which is made one for Mike, one for Ganesh, depending on our
Yeah.
likings and dislikings, and similarly our nutritional requirements. So to answer your question, in summary, access to data, increasing compute capability, and that magic phenomena of somebody having started this thought process of blending these two things have somehow happened. I think the time was ripe a decade back that people started thinking about it. And I have come across many smart and intelligent people in the last around 4 to 5 years who have expressed this thought. Why is it that nobody has done it? And only then they have realized that our lab has done it already. And of course, there is no end to the story. It's an ongoing process. But yes, people have simultaneously around the same time have thought about it. while we have the privilege of having worked on it and put the foundation, but I believe time has come for computational gastronomy to arrive on the stage.
So, talk about the building blocks of understanding that help us arrive at this true digital understanding of food. So I think, maybe this is the different components of your, I think your ratatouille, as you call it, your language, your LLM. Can you kind of define the different building blocks that you have helped over the past decade to understand that help us arrive at a better understanding of how a computational understanding of food?
Yeah. As I said, food is a multi headed beast. It is on one side about sensory experience of how we taste and smell the food, but at the same time, it has social component. It has health associations, nutritional value, and maybe even sustainability, because everything that we eat has its effect on Earth in terms of the carbon footprint it creates. Over the period of time, we have been disentangling this. I call them as the jigsaw pieces of the food puzzle. So one of them is the traditional recipes, because everything that we eat today is by virtue of traditionally passed recipes to us, right? In this part of the world, in India, we eat. India is a very diverse country, but we eat what are Indian recipes, and within different parts of India, we have a variety of cuisines because we are a multi-cuisine, multi-linguistic country.
Yep.
Similarly, you have the French, Brazilian, Southeast Asian, Thai, and all kind of recipes. So recipe is one angle which we have entangled. And slightly touching on the previous question that you raised, until recently we did not have the ways of teasing out the structural elements of a recipe, like the
Mm,
title, the ingredient, the quantity, the unit. So we have been able to use natural language processing advances, and using what are called as named entity recognition algorithms that we have built in our lab, we have been able to tease out these elements from the unstructured data of recipes to build structured databases. So we have something called recipe DB database,
mm,
which has got 118,000 recipes from 74 countries, just to give one aspect of gastronomy, right? Exactly in a similar manner, without getting into details of each one of them, we have been able to find out estimated nutritional value of each of the recipe. Further, we have also got one of the most extensive data repository of flavor molecules that are
mm,
reported in the ingredients, the onions, the tomatoes, the tamarind, and the mangoes. What kind of flavor compounds are reported in them by chemists who have done experiments such as the gas chromatography and molecular spectroscopy. We have compiled it in a single place called flavor DB. Again, one of the most
mm,
extensive single repository available at a single place. And exactly in a similar manner, we have done it for health, which is called dietRx. And now, finally, in the last year or so, we have put together something called Sustainable Food DB, which is about
mm.
the estimated carbon footprint of the recipes. So, last 9 years, we have spent a decade or so, we have spent putting together this edifice, which in its entirety can be called as computational gastronomy.
Great. Well, you can understand, I think, some from the culinary world might have criticism because there's the alchemy, the magic of combining ingredients. And so when I hear about, for example, your flavor components, you can optimize and digitally understand, for example, flavors into like tamarind and etc. What about the relational interactions between different flavors? Is that a part of it? Because that is the magic, I think, in many ways of like when you create this magic recipe, a chef combines this ingredient, and then all of a sudden the combination and the combined flavor is magic. Does your framework understand that relationships between different flavors and the magic that happens when you combine them?
Valid point. Valid point. I'm not denying that. In fact, fun part is this, that my lab is called Complex Systems Laboratory. And
Mm,
complex systems, by definition, have a phenomena called emergence. You are essentially referring to emergence.
mm,
That it's one thing to know an ingredient and what taste and odor does it have, and it's another thing to have two or three or five of them coming together, being boiled, cooked, roasted, sauteed, and thereby there being an emergence of a completely different flavor and aroma, which independently each of the ingredient might not have we might not have encountered, right? So that's what you are referring to. Does our database
Yes.
capture that? To a large extent it doesn't. You what we have been able to do is take a reductionist approach of trying to break down recipes to its constituent elements, break down ingredient into its constituent flavor molecules, and in a similar manner we have done it for other elements. But how do you put it together so as to come up with an interesting recipe is going to be far more interesting, and I don't think we have cracked that code yet. However, thanks to artificial intelligence techniques, which unfortunately don't give us the first principles understanding. I won't be able to tell you that having taken these three ingredients and having processed in a certain manner, how is it that the final flavor arises. But thanks to large language models, for example, which not only are good at capturing the syntax, but to some extent, to a large extent, I would say, are good at capturing the semantics. That is how,
Mm.
if you were to say that write a beautiful poem about a romantic evening in Paris, it would come up with that. If you say write it in a particular poetess style, it would do that as long as enough data is provided. So right now we are taking that data driven approach where a large amount of data, structured data, I repeat, that's very, very important, subject domain specific structured data, when fed into a large language model, hopefully should be able to come up with recipes which are
Mm.
palatable, if not tasty.
Yeah, and like you said, it's all about the data. And if you're ingesting thousands, hundreds of thousands, millions of recipes that chefs have put together, these different magic flavor combinations, the large language model starts to understand, hey, in the past, mint tastes good with this, which tastes good with this spice. And ultimately, if you want to put in the inputs, if you're doing some queries of your large language model, it may be able to spit this out. And to that extent, you've created what is called essentially the Turing test for chefs that puts this to the test, right? So, can you explain a little bit this Turing test for chefs?
Right. So the first thing that we did, having collected all these structured data, was to use the power of large language models um, to come up with recipes, generate recipes, novel recipes. And as you rightly said, it's the chefs, it's the cultures, civilizations which have given us these recipes thanks to trial and error and perfection of various recipes that have been done over millennia, for that matter. But how do you capture the knowledge that has been encapsulated in these recipes such that today's AI technology can give new recipes is one endeavor, which we have done. And we have built an algorithm which we fondly call as Ratatouille, after the movie and the character in the movie Ratatouille. And having done so, the next challenge, which I always get it from my friends and critics, is that, never mind all these new recipes and that you are generating in your computer, uh, cook me something and feed me something
Yeah,
which is
yeah,
palatable, which is of course a challenge given the fact that our server is able to generate a recipe every half a minute. It would be impossible for me to cook a recipe and try it out to figure out how palatable it is. So
right.
I have taken a two-step procedure here, protocol here. The first step is that of the Turing test for chef. As you can imagine, I have named it after Alan Turing, who was one of the pioneers of artificial intelligence. And he wrote a wonderful article way back into 1955 called Can a Machine Think? Essentially, we are extending the argument of Alan Turing to ask, can a machine think like a chef? It's a narrow intelligence and creativity, domain of creativity, that we are trying to see whether an AI program can emulate, can it imitate it? Can we play the imitation game in gastronomy? That's what we are trying to ask. Well, so what we did is to take a stack of real recipes, traditional recipes. We had 118,000 recipes from 74 countries, and then we had equal number of AI generated recipes, those which
Mm,
are generated by Ratatouille, and we created an interface, which a chef can log into. So it's by invitation only, the Turing test for chef interface. Having logged in, the recipe without changing the formatting will be shown to a chef with a equal probability, 50-50 probability. One of the recipes will be shown, and
Mm,
the chef will be left with a job of reading the recipe and giving their judgment about whether the recipe is fake or real on a scale of 0 to 5.
okay.
And the idea here, assumption here is that an expert chef who has been trained well for around 4 years in the school of culinary school would have read large number of recipes and would
Yep.
be able to find out a recipe which is seemingly consistent in terms of taste and odor and combination of ingredients and how they are processed, and should be able to identify any obvious and not so obvious flaws in the recipes. That's the assumption I'm making. All right. Having done so, we conducted this taste with 24 chefs in Institute of Hotel for Hotel Management, PUSA, in Delhi. It's a
Hmm.
Delhi-based
Yep. Yep.
institution. In fact, it is in India. It is the best institution that you can ever find. And then we found that we have an F1 score very similar to that of an accuracy of around 70%. Well, which says that we haven't done a job as good as we should have done, maybe 90% or 95%, but at the same time, it is not so bad. So we are able to crack the code partially. Now we are going to the next level because our algorithms have
Mm.
improved from what we had developed way back in 2020. And we hope to now take that score from 70 to maybe 80, 85, if not 90.
Have you thought about doing this in other geographies like France, like America, like Japan?
Yes, yes, pretty much. I would like to do that. So much so that I'm ambitious of taking some of these recipes on MasterChef, if it can be done.
Oh yeah,
And
that'd
that
be
would be,
great.
yeah, that would be an adventurous thought. Don't you think so? Right?
The ultimate
Yeah.
man
So
versus machine.
yeah, man versus machine. Can we do that? Of course, that's a long shot. Maybe a moon shot or a spoon shot. You might like that, Mike. So
Exactly.
it's a yeah. So, but then what we are doing is this: that ratatouille, we are we are creating versions of ratatouille which are fine tuned for creating recipes for different cuisines: the
Mhm.
Indian, French, Brazilian, Mexican, Southeast Asian, etc. And ideally, as you rightly said, we would like it to take it to different countries, have it validated by the chefs of those countries, in the sense those who are expert in those cuisines. And having done that, the next stage would be identify the subset of recipes which in computer science jargon is called false positives, meaning recipes which were computer generated, ratatouille generated, but were successfully able to fool a chef into thinking that they are genuine, they are traditional recipes. Such recipes we would like to have it evaluated by cooking them. It is resource intensive job, but we would like to actually cook them and have it evaluated for their taste, aftertaste, palatability, mouthfeel, and other
Mhm.
characters, just to evaluate how well we are doing in terms of cooking the recipe. So that's my two-step protocol. Having generated the recipes using AI, go to Turing test for chef, and then take it to the next level where you actually cook it. Because you know what, next level you can only cook so many because it being a resource intensive exercise. Well, that's what we intend to do right now.
That's great. You also talk about in your work the applications on personalized nutrition, and I think there's some understanding in the model you're building of, okay, this can be have this impact on your health as in a food as medicine context, et cetera. Can you talk about that a little bit?
That's right. I'm not the first one to be talking about it. Uh, People have worked on it. For example, way back in 2015, Weizmann Institution, there was a team of researchers who came up with this idea. There was a paper published which essentially said a couple of things. One, if I were to take a nutritional or a health parameter, for example, type 2 diabetes, which is tightly interlinked with postprandial glucose level, post meal increase in glucose. Now, if you were to look at the data of how people respond given a standardized diet, turns out that for the exact same diet, various people respond completely differently, and their blood glucose spikes differently. suggesting that
Right.
a generic advisory about what you should or should not eat if you have type 2 diabetes of a certain level is doesn't work. That was first take home message from their study. And the second one, which is more interesting, is that to be able to manage your type 2 diabetes, and if not find a way of curing it, then the way to do that would be to build a machine learning model, an AI model, which
Mhm.
takes a lot of parameters like height, of course, the basic parameters such as the height, weight, gender, activity level, but also gut microbiome, what meal I am consuming over the day, and a couple of other parameters, so as to see build a model wherein they took a set of subjects which are around 850 maybe, and they built a model to show that as opposed to what a dietitian or a nutritionist would predict, compared to that, this so-called random forest model does a far better job in suggesting what I should eat if I have type 2 diabetes versus what Mike should eat if he were to have type 2 diabetes. That's a beautiful direction in my opinion, because it allows us to stick to the kind of diets that we like. I might be a person, somebody who likes North Indian food a lot, and therefore it would recommend me within the genre of North Indian food, which food should I be eating if I had type 2 diabetes. For example, that's personalized nutrition for you. And if it can be brought to scale to anyone and everyone, not only those haves but even the have nots, if they have access to it, that would be a fantastic thing to happen, and it will be a revolution in the in the space of public health, in my opinion.
Looking at the world of gastronomy and AI being applied to it, where does this all going? Do you think, 10 years from now, 20 years from now, every chef will have a computer terminal or maybe a voice assistant or something that they're using as their assistant to make better recipes, etc.? Or uh, it'll just be a subset of people? And where does this feature set go in terms of like using your models to help us cook? Will we just all be eating better, more personalized, nutrition oriented food in the future? Talk about where you see it all going.
Yeah, I might be you know uh, somebody who is already biased about it, since I've been working on it, building a foundation for it. But I have already been my critic, and I keep talking about my research at so many places that I always come across people who see the counterpoint about why what I am doing in computational gastronomy is not the right thing, or how the models can be biased, um, how they can be unsafe, how they can be misused. So I have come across all of those arguments. Nonetheless, like it happens with any good technology whose time has come, I believe the technology of computational, or the time of computational gastronomy, time of AI as applied in the context of food, has already come. Never mind whether Ganesh Bagler will do it or not, whether his lab will do it or not, people will do it. They are already doing it. Within industry, in academia, and outside, people are already doing it, experimenting with it. So, where I see it is going is this direction. Well, by the way, many people are scared, especially chefs. They think that AI will take their jobs away. My personal take on that matter is that AI won't replace a chef, but a chef not using AI will be replaced by a chef using AI.
Hmm.
That's what I think. The way you said earlier, I believe that a large proportion of chef, if not all, will be using one or the other aspect of AI in terms of the data-driven approaches. People are already doing it, but how to ask, like, what other ingredient can I replace this ingredient with? What new recipe can I make which is non-allergic? What new gluten-free recipe can I make? Can I make a vegan recipe which tastes like so and so dish? These are very, very interesting questions, and I believe AI has the potential for answering them, even while keeping in mind that I'm always reminded of that cartoon where Dennis the Menace, the Dennis has already taken the car, broken the car into its component, and he's sitting in front of it thinking, how will I put it together? So through a reductionist approach, we have broken down the ingredient into its flavor, recipe into its ingredients, etc. But how do you put it together? How do you make sense of it? It's still a black box. We still don't understand it. But thanks to AI, looks like we are at a place where we can build applications which will be of value to anyone and everyone, including chefs.
Real quickly, before we go, how did you get started? Like, go back way back. You're a university student. How did you migrate and navigate yourself in your career towards this world of computational gastronomy? Where to start?
Well, yeah, okay. It was serendipitous. And if I were to think of it, then I would go back to this gentleman called Nassim Nicholas Taleb, the author of Black Swan and Antifragile. So I have been influenced by his philosophy for a long period of time. And he has this idea called barbell, wherein different aspects of life where there is a dominance of uncertainty, you should be taking a barbell approach where
Hmm.
you should be dealing with two different extremes, is what he tells. I won't get into the illustrations, but as a researcher, I learned that I shouldn't be only working on research ideas which are long term and expensive and will take a lot of effort from my side, but I should be also experimenting with tiny ideas, interesting ideas, which are like I can work on for a semester or so along with my intern students. And if it works, fantastic. Never mind if it doesn't work. That's how I started off working with variety of small ideas, right from lung ventilation to food pairing. My first exploration was food pairing when I was still in IIT Jodhpur, one of the Indian Institute of Technologies. There was an assistant there. I was an assistant professor, and that's when I started working on this in a classroom, believe it or not. I
Hmm.
brought this idea in a classroom, and eventually ended up developing it as a research project. Engaged a couple of students who were adventurous enough to work on this idea, which seemed so esoteric, about looking at cuisines, recipes, and trying to find out what kind of food pairing phenomena does it have. And finally, when we worked on it, we ended up getting some interesting results. And long story short, I realized that there are three things that can, I mean, over time, I did not realize it overnight, but three things that are happening here. I encountered a green zone or a barren zone where there is hardly any work done on the interface of food, cooking, and computation.
Hmm.
Nothing, almost nothing. Very little bits and pieces of work. So academically, it was, you do anything interesting and it will be cool work done. So that was one part of it. Second, I had not earned a single dollar out of my research until then. But soon after this work, some of these companies, multinational companies, started running after me, asking me to work for them on a small, tiny, tiny idea, and they were willing to give me some money. So I realized that there is a huge monetary potential in it. Second thing. And third, importantly, I realized that there is a huge social value attached with it because food has got such a huge food and nutrition related consequences. So that's how the story spun over a period of time. And of course, I have taken risks. I have taken risks, and it would have been an academic harakiri. It was academic harakiri, according to my colleagues. Why are you working on topics which are so esoteric? Nobody, I mean, you will be a nobody if these things don't work. But I saw some potential in it, and I ended up building it. I was not alone. I had the luxury of working with my research interns, more than 200 of them who have contributed. But it has been a beautiful journey, adventurous journey. And of course, I'm writing a book out of it, incidentally.
Great. When's the book out? When's it going to be out?
The book will be out sometime in the month of March or April next year.
Great.
Yeah, tentatively, it is called Making Food Computable, or it might get a digitally delicious title also, one of those titles probably. But yes, next year, early next year, you should get the book in your hands.
Awesome. Well, Ganesh Bagler, someone who's dedicated his life work to computational gastronomy, thank you for spending time with me.
Thank you, Mike, for having me on your show. Wonderful talking to you.